Good evening, everybody. Thank you so much for joining us today for this session, especially on a Monday evening. We really appreciate it. I'm Kriti Bharti. I'm a senior product manager with AWS IoT, and today I will be talking about how you can leverage AWS IoT Device Defender to keep your IoT devices secure. Joining me today will be Atul Bargaje, Principal Consultant with AWS Professional Services, and Rama Katragada, Solution Owner for Connected Labs at Thermo Fisher Scientific. Today, we will be talking about the challenges associated with IoT security, talk about how AWS IoT Device Defender can help you mitigate these challenges. Atul will run us through a demo of the service, and then we will dive deeper into the Thermo Fisher use cases with Rama. Here are some other related sessions that you can attend in case you are interested in IoT security, and here are the repeat timings for these sessions. Let's first talk about why security is considered the #1 adoption blocker for security for IoT among enterprises. Let's look at the few security incidents that made it to the news cycles recently. In 2014, we had smart refrigerators sending spam emails. So your innocuous refrigerators, in addition to keeping your water cold, was also participating in spam email campaigns. In 2015, hacked cars made the news, where hackers were able to get unauthorized access to the car, open the car, and even in one case, made the car to go off the road. 2016 was the year of the Mirai, leading to one of the biggest denial of service attacks on DIN, as well as trying to wipe the nation state of Liberia off the internet. Personally, for me, 2017 was the most concerning year, with hacked pacemaker and cardiac monitors. These devices could be hacked to deliver life-threatening electric shock or even forced to malfunction. These are just a few of the incidents. There are other IoT abuse scenarios that concern the security professionals in the IoT worlds. We have the denial of service attacks in which IoT devices prevent access to legitimate web services. We have the lateral threat escalation in which hackers can use IoT devices to bypass perimeter security and get access to other IT resources, sometimes more critical IT resources. There can be information theft and surveillance, such as theft of intellectual property or still images from your connected cameras. There are cloud infrastructure abuse, where hackers can rack up the financial loss for your IoT business. Then there's also the ransomware and the sabotage attacks, where devices can be forced to malfunction. So imagine, if you will, you are a commercial connected sprinkler controller system, and your devices have been hacked, and your sprinklers are made to go off in a prestigious public event. These are just few of the IoT abuse scenarios that are commonplace in IoT. Why are these so commonplace? What are the challenges associated with IoT security? IoT has a complex ownership model in which there are several layers of resellers between the device manufacturer as well as the end user. This makes it very difficult to identify who is the right stakeholder to inform. The lack of vendor support make it very difficult to patch security vulnerabilities. The usability issues and the pressure to get to market as soon as possible can lead to coding errors or default hard-coded credentials which are weak. Additionally, IoT devices are not designed with security in mind. Security is an afterthought for these devices. All of these factors combined can lead to circumvention of best practices and very difficult to alert the right stakeholders when security issues are identified. To make matters worse, hackers are in the business of providing botnet setup as a service. They misuse products such as Shodan, ZMAP, and Census to identify vulnerabilities and insecure configurations for internet-connected devices. So what is it that an IoT security system should have? AWS, for all our services, has a shared security responsibility model for our customers for security. AWS provides security of the platform, and our customers are responsible for building secure applications. So we provide the security of AWS IoT core platform, and our customers are responsible for building secure IoT applications. AWS IoT provides mutual authentication for your devices as well as for AWS IoT core. We support fine-grained access control through IoT policies for authorization. So you can use, for example, control the devices and control which topics they publish data to or subscribe data from. We also support encryption for both data in rest as well as data in motion. These security building blocks need to be augmented by functionality that allows customers to monitor the runtime behavior of their IoT devices, because security is only point in time. And what is secure today may not be secure tomorrow. AWS IoT Device Defender helps our customers meet the security objectives for their IoT applications. We have a feature called Audit that helps our customers prevent security incidents from taking place by making sure that the configurations of their IoT resources are secure. We have a feature called Detect that continuously monitors the device behavior and identifies any anomalies. Any security issues that are identified are alerted, the customers are alerted upon, and then they can investigate and mitigate these issues. So the behavior of these devices, of IoT devices, are very well understood because they are usually single-purpose devices. So any deviation from expected behavior is something that the customers would want to investigate. The way it works together is that the devices sample high-value security metrics at a predetermined frequency, which is configurable, and report it in MQTT to AWS IoT Device Defender specific topic. So the whole pipeline works just as if you were publishing your telemetry data to AWS IoT Device Defender. The AWS IoT Device Defender also gets metrics from AWS IoT Core, which are associated with your device activity on AWS IoT. AWS IoT Device Defender also gets the IoT resources associated with your devices, and then aggregates your device metrics to make sure that they adhere to the behaviors that you have defined and identify any anomalies, and makes sure that your IoT resources are configured securely. If there are any issues with either your IoT resource configuration or your device behavior is identified, it is published to AWS IoT Console and also to Amazon SNS and Amazon CloudWatch. Customers also have the option to use AWS IoT Device Management to mitigate the security issues. Customers can leverage the Device Jobs feature of AWS IoT Device Management to take remote actions on the devices, such as pushing a firmware update or rebooting the device or resetting the device to a factory default setting. Let us dive deep individually into the features. Audit helps customers audit the IoT resources associated with their devices to make sure that they are configured securely. Customers enable from a set of audit checks that act on various resources, such as their certificates and policies. These checks are mapped to security best practices recommended for AWS IoT. Audit looks for any expiring or revoked X509 or CA certificate. AWS IoT Device Defender also looks for any IoT policies that are overly permissive or any cognito identities that have overly permissive access. So audit will flag, for example, any IoT device which has an IoT policy defined that can allow it to publish or subscribe to all topics. It will also flag cognito identities that have the permissions to perform administrative actions. Audit also monitors the runtime behavior of your devices to look for things such as devices that are connecting using the same client ID simultaneously. Per MQTT specification, when devices are in a colliding client ID scenario, they knock each other off the IoT core platform, which could lead to loss of data or even prevent an authorized device from getting access. Audit also looks for devices that are connecting to AWS IoT using the same X509 certificates. And lastly, audit looks for your account to have logging enabled in case you need to get access to your logs to investigate any potential issue. Customers can, I'm sorry, did you have a question? We will take Q&A at the end. Do you mind waiting until then? Thank you. Customers can schedule their audit report findings to be sent to them either on a periodic frequency of daily, weekly, bi-weekly, or monthly, or they can schedule or run an ad hoc audit as per their business need or use case, such as during vulnerable periods such as production deployment. Why is audit important? It is easy to make sure that the configuration of your one IoT device is secure. It's even possible to do it for 10 IoT devices. But when you are talking about a scale of millions of devices, configuration drifts do occur, and your IoT devices can deviate from recommended security best practices. AWS IoT Device Defender's audit function helps you prevent security incidents from taking place by making sure that your IoT resources are configured securely. Let's talk about Detect now. Detect provides you rule-based anomaly detection. You can define two different kinds of rules for high-value security metrics, such as the IP destination addresses that your devices are communicating with. So one kind of behavior that you can define is a blacklist or a whitelist kind of a rule, such as blacklist, a port number, or whitelist, an IP address. You can also define a threshold kind of a behavior for security metrics, such as number of bytes or number of packets. For easier management, you can collect a group of these behaviors and organize it in a security profile that can be attached either to a group of devices or all of your devices in your account fleet for easier management. AWS IoT Device Defender will alert you as soon as a device is reporting a value that violates a blacklist, whitelist behavior, and it will aggregate your threshold behaviors and metrics over the configurable unit of time that you have defined. On the device side, AWS IoT Device Defender allows you to define behavior for the number of incoming and outgoing packets, bytes, the destination IPs that your device is communicating with, the number of open TCP connections you have, as well as the number of ports and the port numbers that you have on the device. On the cloud side, AWS IoT Device Defender collects these metrics based on the activity associated with your devices on the AWS IoT core. So we look for number of incoming and outgoing messages, message size, source IP addresses, number of connection attempts, number of disconnections, as well as the number of authorization failures. Let's look at how these metrics are useful in anomaly detection and identifying the IoT abuse scenarios. If you have a sample denial of service case, your number of outgoing packets or bytes could go up, or you may have number of unnecessary ports open your devices, or those ports might be communicating with on suspicious port numbers, or your devices might be communicating with suspicious IP addresses. Any of these indicators by itself or combined together could be indicative of a denial of service attack. Let's look at that now for the cloud side metrics. So let's say, a cloud infrastructure abuse. If your number of messages, incoming or outgoing messages, are going up, or your message size is going up, or if you're seeing communication from suspicious source IPs, these could be indicative of a cloud infrastructure abuse. Similarly, AWS IoT Device Defender helps you identify indicators of compromise for all of the IoT abuse scenarios that we discussed earlier. I am now going to invite Atul Bargaje from AWS to run a demo of the detect feature of AWS IoT Device Defender. He will be followed by Rama, who will be diving deep into the Thermo Fisher use case for IoT security.
Thanks, Kriti. Thanks, Kriti, for telling us about all the cool things Device Defender can do. Now let's try to apply these things to real world. Let's get our hands dirty and see how we can use some of these things to solve some real world problems. So here's the situation. Your company is working on this next generation cool car, and everything at the shop floor where the car is being manufactured is being carefully monitored through a set of security cameras. Now, the security cameras are part of an AWS IoT group, but for the sake of demo, what we are going to do is we're going to install Device Defender agent on just one of these security cameras. A hacker shows up, and the security cameras that are monitoring your next generation supercar have a telnet port open on them. I know, not the best choice for technology, but the company that manufactures these security cameras has left the telnet port open to do some diagnostic and troubleshooting for them. The hacker manages to exploit this security vulnerability and inject these security cameras with a malware. Now, all your video feeds that are being sent to your monitoring center are also flowing to hacker's server. So all your trade secrets are being stolen by this hacker. But since you have a Device Defender agent installed on the camera A, and unusual activity is detected, and you are able to take mitigation actions, or you can quarantine the camera that is sending this, and you can take appropriate actions to make sure your trade secrets are not stolen any further. So let's see this in action with a live demo. So first, let's see the cloud side of this demo, the cloud side setup. All your cameras are part of IoT group called reInvent 18 Demo Cameras group. So camera A and camera B are part of this group called reInvent 2018 Cameras group. In real world, all your security cameras would be part of this group. But remember, only camera A has Device Defender agent installed on it to show you the difference that the Device Defender agent makes. We also have a security profile or Device Defender profile defined, which basically has a behavior that flags any device which sends more than 15 MB of data over a period of 5 minutes. So our devices or all our cameras are supposed to send at max 10 MB of data over a period of 5 minutes. So that's the setup we have. And we have associated this security profile with this group we saw earlier, reInvent 18 Demo Cameras. So all the cameras in that group, IoT group, will be monitored. So now let's go to our monitoring console, the command center of your company, and let's kickstart our command center. So our command center is running now. This command center is supposed to receive all your video streams from your shop floor where your next generation supercar is getting manufactured. Now we'll go to camera 1 and we will start a device defender agent, camera A. And we are going to start the device defender agent only on camera A. So here is the device defender agent running, and you should see this message where it says the shadow updates are being accepted by the device defender backend, and that tells you that the device defender agent is publishing the metric to the backend and is monitoring all the activity that is going on that camera. Now we are here on camera B. No, sorry, we are still on camera A. And we are going to start the camera software that is going to start uploading the video feed of the camera to our command center, to our company's command center, where all the activity is getting monitored. So what this software is doing is it's uploading about 10 MB of data every 30 seconds, well within the 15 MB limit we have set for all our IoT device. And as you can see, the camera A files are being received on our command center. So here's the command center, and camera A files, camera A 2018 files are being received by our command center. And every 30 seconds, these files which represent a video stream are being sent. Now let's go to camera B and just start our camera software, which is supposed to send the video feed of the camera. Notice we haven't started the device defender agent on camera B. So camera B does exactly the same thing as camera A. It starts sending the video feed, and you can see over here the camera B video feed is being received by your company's command center as expected. So everything is going fine, your car is coming along nicely, your next generation supercar is carefully being monitored by your command center, and all the files are getting uploaded to your command center. But a hacker shows up in a minute, and the hacker is going to start a web server which the hacker expects to capture all the video stream from your cameras. So let's go to another, and all of these things are being simulated through EC2 instances. So here is an EC2 instance that represents hacker's web server. So we are going to start a hacker's web server, and the plan is this web server will receive the feed from cameras as well. Now what we are going to do is we are going to launch an attack on camera A. We are going to launch a telnet attack, and through this telnet attack we are going to inject this malware.py over here into camera A, and this malware will start sending the video feed to the attacker's web server. So in addition to going to your company's command center, this video feed is also being received by hacker's web server. Now we will do the same thing. We'll launch another attack on camera B. In real world, all the cameras would be infested with this malware. And as you can see, the .50 IP address, which represents our camera B, is being infected with this malware. And here you can see the files are being uploaded to the hacker's web server. Right, so the attack has gone through, and you can confirm that the attacker is receiving files from camera A as well as camera B. This is the attacker's web server, not your company's monitoring server or command center. So the attacker is stealing all your trade secrets at this point, and all the video files are being received on the attacker's web server. However, since we have Device Defender agent running on camera A, the AWS IoT Device Defender raises an alarm. And you can see that alarm being raised over here. And that alarm is raised because the bytes sent out by camera A exceeded the 15 MB limit. And the reason it happened is the camera was supposed to send at max around about 10 MB files to the monitoring center, but since it started sending about same amount of data to attacker's web server, that traffic got doubled. And it exceeded the 15 MB limit we had set for cameras to trigger this alarm. And as a result of this alarm, you can quarantine that camera and take appropriate action. But as you can see, camera B didn't raise this alarm, right? So because we had Device Defender agent running on camera A, we could identify this unusual activity and raise an alarm. So that concludes our demo. For next part of this session, I'm going to call on Rama from Thermo Fisher. Rama is leading the connected lab effort at Thermo Fisher, and he will tell you more about how Thermo Fisher is using Device Defender at his company.
Thank you, Atul. That was a great demo. Good afternoon. I'm super excited to share our connected lab journey, how it started, where we are, and how IoT Device Defender helps this journey much more secure. So with that, we also wanted to thank our AWS partners, Tensor IoT, who's been a great partner with us on this journey. Let me start out with a little bit of background about Thermo Fisher Scientific, who we are, what we do, and why is Connected Lab an important initiative for us. Thermo Fisher Scientific is a world leader in serving science. We have approximately about 70,000 colleagues globally. We have about $20 billion revenue, and we have unparalleled commercial reach to our customers. Our mission is to enable our customers to make the world healthier, cleaner, and safer place. To do that, what do? We make products like instruments, equipment, consumables, and software that will empower the scientists in the labs to solve the complex analytical challenges in various verticals that include pharmaceuticals, biotech, education, academics, industrial, environmental, and clinical labs as well. So with that, since we are the leaders in the space of the equipment, we reached out to our customers and asked them, what are the challenges you're facing when you're in the lab? When we talked to the lab scientists, for them, the main challenge was they wanted freedom. When they're running an experiment, they didn't want to stand there all day looking at the experiment and monitoring the experiment. They wanted their hands free and they wanted to do some other things. The other thing was managing the scientific data. These instruments generate megabytes and gigabytes of data, and they wanted an easy way to manage this data that could be shared with other customers, other collaborators, without having to manually copy, which is very time consuming, and also can have security risks as well. So those are some of the pain points the lab scientists were telling us about. We talked to the lab managers. For lab managers, reducing the downtime is very significant. Otherwise, it will have a very negative impact on the experiments the scientists are running, and also the quality of the samples that the instrument or the equipment is storing. With that as a background, we said, okay, what would, if you were to build a lab of the future, what would that look like? So this is what we put together, right? In the connected lab, where if these capabilities exist, where customers can monitor their instruments, their equipment, they could do remote diagnostics to reduce the downtime, and also the scientists could start sharing and collaboration. Those are some of the basics. On top of that, if you were to build more services, this would be smart services and support, smart connected workflows. Because in the lab, instrument doesn't alone is not enough. If you make them smarter and if they have a connected workflows, that improves the productivity and accelerates the innovation in the science. So those were the main goals for us to we embarked on. At the same time, at the company itself, we had a charter to every device that's coming out of Thermo Fisher Scientific has to have a built-in connectivity to support this initiative. With that, we launched quite a few. This is a sample of instruments that we launched in a couple of years. If you look at them, they have a consistent user experience. They also have ability for the scientists to set the experiment remotely. They don't have to be standing in front of the instrument to set up the experiments. They also can easily download and share the protocols with other collaborators. At the same time, since all this data is being streamed, it's easy for them to securely share the data with the collaborators around the globe. So those were the basics that we talked about, and we achieved those. And if you look at the mobile workflows, so some of the scientists, I don't want to be standing there the whole time. I should be able to monitor my run remotely. So we have created mobile apps where the customers can monitor the run status in real time. They can even view the results as well, right? And the other one was, since it's a shared lab, there are a lot of these instruments that they want to check for availability. They don't want to go into the lab and find out that instrument is not available. So they want to have the ability to check if the instrument is available and schedule it. So this is where we solve the use cases for the lab scientists. That's only half the story, right? We still have a lab manager who is very nervous about the samples in the lab equipment, in the refrigerators. So let me walk you through this slide. This is a little bit of a busy slide, but let me break it down a little bit. So if you look at the right-hand side, the smart devices, these are the ones we talked about, where these are the ones that have built-in connectivity, that can stream the telemetry data to the cloud easily, the scientific data, and have the other capabilities like sharing, collaboration, asset management. That is category 1. Category 2, the middle one, these are the set of instruments that are shipped with the tethered PC. They were never connected to the cloud, but we have developed software that is deployed on the tethered PC that gives them digital connectivity. Thus, these are also reborn digital. They have now the ability to stream the telemetry data, scientific data, and they all have the same benefits as the smart devices. That still doesn't solve the problem with the lab manager, who is very concerned about his refrigerators, his freezers, and the incubators that have these samples. So we went back to the drawing board, and these instruments, these lab equipment, have a lifespan of anywhere from 15 to 30 years of lifespan. So how do we make sure we make them reborn digitally? With the intent of that, we created a hardware device called Device Link Hub, and that Device Link Hub, when connected to this equipment, gives them connectivity. And by connecting, you get the temperature history, alerts when the temperature falls outside the range, and it also notifies when somebody left the door open, right, or you lost the power. So with that, we launched this Device Link Hub. So what is so unique about this Device Link Hub compared to the other monitoring solutions you have in the industry, right? There are two unique things, at least, that I think of. One is, this does not require installing any additional sensors. This directly plugs into the data port of your instrument. It reads the data from the data port and sends the data to the cloud. In this particular instrument, the ULT refrigeration unit, it's about minus 80 degrees centigrade. That's where, that's the temperature these things maintain. And we send about 50 data samples. That includes the compressors, includes the power, includes the various vibrations on the instrument to the cloud. That way we can do not only monitoring, but predictive maintenance as well. The second cool thing about this device is it requires minimal IT support. And it has the user experience of a consumer device. The customer should be able to install them like they install Alexa at home. That's the kind of experience we were going for. Since these are consumer devices and we don't have a field service agent going into the field and installing like we do for the smart instrument, that poses a challenge. How do we make sure that these devices are secure? That's where we look at the IoT Device Defender to make these devices very secure. Let me briefly talk you through the architecture slide, and then I'm going to talk through the use cases, and I'm going to invite Ravi to give us a quick demo of that. So on the left-hand side, you have all these devices transmitting the data, sending the data to the aggregator, and the aggregator is the one that communicates the data to the cloud. And the whole Connected Lab initiative is built on the AWS IoT platform. So we leverage several IoT features, including the ML, the SageMaker, and those services as well. With that, let me get into some of the use cases that are more pertaining to this talk. Right, so we have this is a sample of the use cases that we're working on in our next version of the product. So we have 2 use cases for audit and 2 use cases for detection. In the case of audit, if a certificate is shared between these 2 devices, we should be able to detect them. Some of the enterprise customers also want to have the policy to rotate the certificates. That's another one where we are using the audit mechanism. In the anomaly detection, this is where we want to see if a device is sending the data about the baseline, what we think it should be. That's another use case we are developing for that now. And the open ports, if anything outside the standard ports are open, we want it to be notified. And this is the process it happens. When we audit and we find out there is a shared certificate, we detect, then we alert the SNS to our dashboard, and then we quarantine that device and the certificate. And in terms of the detect, if you have any open ports that shouldn't be opened, or if the messages that are coming out exceeds the baseline, then we do the same process of quarantining and revoking the certificates. And the third one, this is the enterprise need, where certificates are required to be rotated. We check for the certificate expiration, trigger the certificate rotation workflow, and we provide a new certificate to the device, and at that point, the device starts communicating with the new certificate. So those are the various use cases. Thank you for your time, and now I would like to invite Ravi, who's been a great partner for us in helping us with this journey.
Hey folks, I'll keep the intro quick. So my name is Ravi Raghunathan from Tensor IoT. We're an advanced AWS consulting partner, and we focus on IoT and machine learning type use cases. And today we are gonna talk about, you're gonna see another demo, and we're gonna talk about both the audit and the detect use cases in the demo. As in the audit use case, what you're gonna see is that we're gonna connect a device using a certificate that's gonna expire in the next 3 days. And you see that the device defender is detecting that part that is expiring, and it's going to rotate that certificate for you. Let's get into it. And I've actually pre-recorded the demo so that you don't have to sit and watch things happening, right? So in the audit, as we already spoke about, you can schedule an audit, if you will, where you can select which items that you want to audit on. And at the end of the thing, you can schedule an audit on a daily basis, or if you want to audit once every couple of days, or you can even do an on-demand audit, right? And at the end of the audit, you'll see that there's an SNS tied to it. So that's where the alerts gets generated, and you can have Lambda or your application logic behind that to do whatever you want to do. The other part is you can actually have a on-demand audit. You can come in here and say, hey, I want to only audit for the device certificate expiring, and run it right away, and it's fairly instantaneous once you run it once, and then you can see that the results are appearing right there to say, hey, whether the device is compliant or not. So what we did was we have a CA registered, and we have a certificate that is actually going to expire on November 28th, 2018. So now what we're going to do is have a client use this certificate and connect to AWS IoT so that the AWS IoT Device Defender can then detect the fact that it's connecting with a certificate that is going to expire. So as you can see, I hope you can see it. So the client is connected, right? And the on-demand audit, you can actually raise the on-demand audit from the UI, or as with every AWS service, you have a CLI that you can raise it with as well, start it with as well. So here we have a CLI command that is going to fire off an on-demand audit. And as I said before, as soon as the audit is fired, the system is going to run it. There's going to be an SNS notification that gets generated, which is tied to a Lambda, which is going to start the certificate rotation process, right? So let's see what happens now. I'm going to go ahead and kick off the audit, right? Once you kick off the audit, you get a task ID, which is essentially telling that this is your task ID if you want to query on top of that ID as to say what's the status and so on. Once I refresh, you'll see that the run was fairly instantaneous. It found that we are not compliant, and there is a one non-compliant item, which is essentially the device expiration issue, right? And as you can see that, now if you go to the client side, it says it has detected the certificate is expiring, and it has initiated the certification rotation process that will essentially vend a new cert, and then the client reconnects. So that's the demo for audit. The next demo is detect. So Atul showed a demo on how you can identify that when a lot of data is going in, you can identify the anomaly and detect it, right? So now let's take it a step further, where if your device is having more than predefined number of ports open, or if your device is sending even with the other demo, if your device is sending more than the defined amount of data, the best thing for you to do is you analyze it, and in some cases you just need to boot the device out, right? You need to either revoke the cert, disconnect, delete the device, and that's what we're going to do in this demo. Again, this demo I've recorded as well so that you don't have to sit and watch. So in the Device Defender, you're seeing that there's a violation screen and security profile screen, where in security profiles you can define what does your baseline look like. In the sense here, you're going to see that there's a profile for bytes and there's a profile for connection. The bytes, we have configured 1300 bytes. I know it's less, but for the sake of demo, and it aggregates it every 5 minutes so that at the end of 5 minutes, when there is a problem, it's going to start creating violations. And on the TCP connections is, at any given point, there has to be less than 49 TCP connections in the device, from the device, right? And both of this, again, is tied to an SNS topic, which is going to connect it to a Lambda, which, again, can do whatever actions that you want to do, which is either revoke the certificate, raise some sort of an alarm, or whatever you're going to want to do, right? In this case, what we've done is, if such activity were to happen, we just delete the device, delete the certificate, and kick it out. So, and you're going to see that happen as well. So once we go into the next screen, what we're going to see is that we're going to open two terminals, actually one terminal. We're going to create a device agent. So have some helper script that can create an actual agent for us. So once we create the agent, we're going to use that agent to run your data collection job, which will then send the metrics over to AWS IoT. And Device Defender will then take the information from that agent and do some anomaly, detect the issues that are happening, both on the port side and also on the message side. So once we run the agent, as you can see that the agent is now collecting the data and sending the metrics over to AWS Defender. And let's go to the violation screen on the Device Defender. You will see that in the violation screen, there are no violations detected yet. But as and when it starts sending more, because we have the 5-minute window, it takes 5 minutes for it to detect. So we have speeded up the video. But now, once your violation starts coming up, you will see that it has now detected both the violations for the message size and also the violations for the port number. It has now, we're going to refresh, and it's going to see the messages. So that's what has happened. So your Device Defender has now found the violations. And what essentially happened behind the scenes is that once the violation has been identified, it will then kick off, send an SNS alert. The Lambda will kick off, and it would have deleted the device and removed the certificate. And that's what we're going to see now, that the device on the right-hand side will get booted out because that has happened. So if you look at the CloudWatch, you see that the device has been deleted, the policy deleted, the certificate deactivated. And on the right-hand side, you'll see now the device got booted out. So essentially, this is taking to the next level where you can protect your infrastructure and your device by essentially deleting the device or deleting the certificate when there's a problem, when you detect a problem in your certificate. This is one logic. You can, because it's SNS and Lambda, you can implement your own application logic, but this is an example that using AWS IoT Device Defender, what you can do. That's it. Thank you. I'll hand it back to Kriti now.
Thank you, Ravi. To summarize, AWS IoT Device Defender can help you audit the IoT resources associated with your devices to make sure that they adhere to recommended security best practices. AWS IoT Device Defender also continuously monitors the device behavior through high-value security metrics to identify any behavior that could be indicative of an attack. It sends the alerts on the AWS IoT Management Console, Amazon SNS, Amazon CloudWatch, and provides you with enough contextual information, historical information, and in some cases, even recommendation that you can follow to fix the identified security issue. We do not take any canned responses because we do not want, AWS IoT does not want to take any action that could bring down your production fleet for any length in time. However, with the help of SNS, you can basically open the entire world of AWS services and can take automated action that may serve your use case better, just like Ravi demonstrated. So why should you care? Because IoT devices need to be secure and IoT data needs to be reliable. Security is not a commodity. One size does not fit all. Our customers need an IoT solutions that is customized for their use case. They want to use a mechanism that can evolve with the evolving threat landscape. And we have already seen first steps coming in the regulation. IoT is everywhere. We are living in a world of connected devices, whether we like it or not. Consumers want the smart devices for their convenience and the comfort they add to their life. Businesses want to adopt IoT in IoT to take advantage of cost optimization, operational improvements, and predictive maintenance. So security can no longer be an afterthought for your business. In fact, it can be a differentiator for you. Security is and always has been our topmost priority at AWS. Make it yours as well. With that, I'd like to invite my co-presenters on the stage for any questions you might have. I'd also like to ask Amit Matri, who's a senior developer in the AWS IoT Device Defender team, to answer any questions you might have. So the question is, what are we doing to make sure that the best practices we implement can evolve with time, and then whether we take any automated action. So I'll take the second part of the question, and I'll have Amit answer the first part. So no, we do not take any automated actions for our customers. We don't do any patch management, but what we do provide is the ability for our customers to integrate their device management solutions with AWS IoT Device Defender. IoT services work better together. So you can either use the device jobs features of AWS IoT Device Management for pushing a necessary patch on the devices, but you can also use your own homegrown solution or a third-party device management solution that you might be using. We just don't want to take an action that could be that could not be in the best interest of your business. So let's say you are manufacturing smart connected set-top boxes, and the recommended action is that we are pushing this patch which reboots your device, and your customers are actually in the middle of streaming Oscars. This is not something you would want to do. You would want to control the manner in which that patch is deployed. So we leave that action to you. We just make it easy for you to do so. And I'm going to have Amit answer your first question.
So as you know, security is really hard to retrofit. If you hadn't architected with security from day one, it kind of gets harder as you go along time. With that in mind, AWS provides all the best security practices, like all the documentation, so that when you're architecting your infrastructure, when you're doing your architecture design, you can keep those best practices in mind and follow those guidelines. Along the same lines, we also have you can work with our technical account managers. We have solution architects, our ProServe team, who can help you make sure that you follow the guidelines and architect in a way that you can make sure that your devices continue to be secure, or be in a way that it is flexible in a way that you can add patches towards on those devices. To answer specifically the question that you had about sensitive devices which are in the field, one important thing that you want to do is make sure that you have the ability to do over-the-air updates on the devices. If you find something is wrong with the devices, especially with IoT devices, which can be deployed in very varying environments all over the place, you want to have some capability of being able to do some over-the-air updates. So if you do find something that a device defender, or like you find some vulnerabilities, you can actually go and perform the updates on the device. But there's a lot more best security practices that we provide, and we would encourage you to make sure that you at least follow those when you do your own architecture, so that you're not backed in a corner a few years down the line.
Thanks, Amit. And I'll also add to that, 90% of the roadmap for AWS IoT Device Defender or any other AWS service is shaped based on feedback from the customer. So as new vulnerabilities are identified, or if there are other recommended best practices, then you can rest assured knowing that our team will be working to make sure that we can add other audit checks that map to those security best practices. These are the standard checks that we have today, but that's not to say that this list will not grow in the future. Any other question? Do you need to turn on the mic, maybe?
Can you guys hear me now?
Yes,
Yeah.
thank you.
All right. So first of all, great presentation. Thank you. It was very helpful. The first question is for probably Rama from Thermo Fisher. Is the IoT Defender, is that the only means that you guys deliver device trust, or do you complement that with something else on top of IoT Defender?
So IoT Device Defender is primarily around the security, but we're also finding several other use cases as well, where there's especially around the audit and the detect capabilities. For example, when these are deployed in the field, especially the Wi-Fi signal strength, that's becoming a harder issue for us to maintain. So we're also exploring how we could use Device Defender as well to get those capabilities incorporated as well. Is that the question you had? Or
yeah. The second question is, in terms of baselining these devices, earlier you guys showed in the demo X amount of data is actually going from camera, and that's how you baseline the device, and that's how you generated your alert. For cameras, it's kind of a little bit simpler use case. For other IoT devices, who defines the baseline behavior? Is it the manufacturer, or you guys observe this, and how does that happen?
Thank you. So when it comes to defining the behavior of your devices, for rule-based or anomaly detection, we expect the customers to know how their IoT devices are behaving in the field. A lot of our IoT customers, such as Thermo Fisher Scientific, are early adopters of IoT, and they are very well versed with how their IoT devices are behaving. For any kind of anomaly detection, not just for Device Defender, but for any kind of anomaly detection to take place, it is important for these devices to be grouped together with similar devices that are expected to behave similarly. Your IoT devices are diverse, but they will share commonalities that will make them behave in a similar way. And our customers usually know how to group these devices and what are the right and appropriate thresholds to set for these devices. If there are customers who may not be as familiar as some of the others with how their devices are expected to behave, we recommend starting with low thresholds, so more restrictive rules, and then fine-tune these behaviors as time goes on and as they receive the alerts, so to be able to define more appropriate thresholds. But we will take your question and feedback into mind and look at other ways that we could augment the AWS IoT Device Defender features to help our customers do that more effectively and easily.
Thank you.
Any other questions?
Hey. Hello. Yep. I have 3 questions. I'll probably take them one after the other.
Sure.
The first one is, how will audit cater for different compliances that are based on different geographies? Countries may have different rules around data coming out of sensors and devices, and will AWS IoT and all of the services underneath it manage to cater all of those different needs?
So I'll take that question. So right now, our AWS IoT Device Defender is present in 10 regions that you can find on our websites, the details of which. Let's talk about the GDPR that came out of the European Union very recently. So AWS IoT Device Defender is a GDPR compliant service. If we are catering to either the regulatory landscape of any particular country or any particular region, we will make sure that these security best practices are available for our customers in other regions also. Whether they choose to do it or choose to take an exception from that recommended best practice would be at the sole discretion of the customer. But we want to make sure that our customer, irrespective of which country or continent they belong to, are able to use our service seamlessly and would not have any different experience no matter which region they chose for their deployment.
So for a company that has probably sensors all around the globe, like this could probably be something for Thermo Fisher, the client experience. Would you end up having different compliance policies on devices that are in different regions?
The answer to that specific question is no. As I mentioned,
okay,
our service is, for example, GDPR compliant. So even in the United States or in the Asia Pacific region in which the GDPR regulation did not apply, our service is architected to be GDPR compliant in those regions as well. So if you have a customer, even though they might be based out of Europe, if they have a deployment in any other regions for your, for as you mentioned, they have devices across the globe, they would have no different experience from if they were just deployed within the European regions.
Okay. The second question is sort of quite naive. If I have, I was working on a case where we were supposed to have security cameras that were coupled with AWS recognition. So if in a space like this, if 5 cameras are there and out of which somebody just turns off 3 cameras, is that sort of has stopped data coming into your system? Would that be considered some sort of malicious behavior, and would that be detected?
So you are saying that if you have devices that were reporting data previously and stop reporting data. So yes, so in AWS IoT Device Defender, you can receive alerts for three different categories. One is if your devices have violated a behavior. You also received alert when over time that device might come back in compliance with the defined behavior, or if your alarm is invalidated, which is the third case you're talking about. So it violated a behavior but is no longer reporting metrics. Again, that could be an indicator of a compromise and is up to the customer if they'd like to investigate.
Okay, cool. And lastly, do you have any best practices depending on the type of devices? So out of the whole array of things that AWS IoT supports, have you defined some best practices?
So our AWS IoT Device Defender, just like any AWS service, is meant to serve all our customers. And we provide a service which is flexible enough and powerful enough and robust enough to scale to any kind of device type or any kind of customer use case. So it can support constrained devices such as microcontrollers or even very robust Linux boxes, which could be a part of a customer's IoT deployment. Our service would be able to serve all the wide wide range of those devices. So does that answer your question, or?
Sort of, because best practices could change based on the device that you have. So based on client feedback that you've got, have you sort of collected some of these things?
So we have so for example, when you talk best practices, the feature that comes to mind is audit, and we have a set of standard audit checks that are available to customers. The customers can choose which audit checks they want to enable based on what checks map to their use cases depending upon the device type that they might have. So customers always have the flexibility to configure the service, AWS IoT Device Defender service, according to their use case. Thanks.
Hi, this is Tom. Thank you very much for sharing good knowledge. So my question is very simple. And someone said device certificate rotation feature is very important.
Yes.
So AWS support on a device certification rotation feature, or vendor make customized by themselves?
So if I understand your question is, do we support the device certificate rotation feature? So yes, we AWS IoT Device Defender will identify the case in which your certificates are approaching expiration, either the X509 certificates or CA certificates. We don't take automated certificate rotation actions on your behalf because, in edge cases, a customer may have legitimate devices that might be using those certificates, and we don't want to inadvertently cause harm to a customer's production fleet. However, as I mentioned, AWS IoT Device Defender publishes its alerts to SNS, and then you can actually use our identity APIs that we provide to do the certificate rotation yourself.
Thank you.
Thank you.
Hello, my name is Ravi. I'm from SiriusXM. I manage the IoT services in SiriusXM. My question to you is, let's say you mentioned earlier that in the AWS IoT, the authentication is based on mutual TLS.
Yes.
So let's say if I take the certificate from one device and I put it in the other device, and if it connects, do you detect an anomaly at that point?
So yes, we do identify if there are simultaneous connections being attempted using the same X509 certificate. That is one of the standard audit checks we have available today. Thank you. I think that was the last question. We are on time. Please complete the session survey in the mobile app, and I hope you enjoyed this session. Good evening.